Right now, if you ask artificial intelligence to write a computer program, it looks like it's thinking. It churns out lines of code in seconds. But behind the scenes, the process is incredibly messy. Most AI tools operate on probability. They don't actually understand the software they're building. Instead, they act like a blindfolded worker reaching into a bin of spare parts, guessing which block comes next based on past patterns. Because the system is constantly guessing, it makes mistakes. It grabs the wrong piece or forces two incompatible blocks together. This creates structural flaws that can break the entire program. This guessing game is exhausting for the computer. To build standard software, the AI must read and generate text character by character. This eats up nearly 40 million tiny units of data, called tokens, and grinds on for 18 hours. This context bottleneck forces the machine to track millions of repetitive characters until it loses focus and the code fractures. But what if we could remove the guesswork entirely? What if we didn't have to hope the machine picked the right block? To build truly reliable software, we have to stop treating computer code like a creative writing exercise. We need a system built on the exact, predictable rules of mathematics. This is where the automatic lattice comes in. Think of it as a flawless construction site that exists entirely in digital space. The lattice is a perfectly organized grid. Instead of floating in text, every logical command is assigned an exact mathematical address on this board. Code pieces are geometric shapes, clicking into place only if their address matches exactly. They cannot overlap. This creates an environment where noise and errors physically cannot exist. If a piece doesn't fit the grid's math, it simply cannot be added. The system remains perfectly clean, with no room for the machine to hallucinate a bad connection. By mapping software onto a strict spatial grid instead of a sprawling text document, we strip away all the uncertainty. It creates an unbreakable foundation for digital architecture. To actually build on this grid, we use a specialized intelligence called the Omega engine. The Omega engine doesn't talk in traditional code or English sense. It uses a method where the instructions themselves are treated like raw data. Instead of writing out pages of instructions, the engine generates a pure logical map, focusing only on how functions connect. We can take a massive block of 35 million tokens and compress that same intent down into just 12,000 data points, a 99.96% reduction. Once that tiny, perfect map is ready, the engine instantly expands it. It fills in the blanks to create fully functioning software in any programming language you need, all at once. Because the engine is working with math instead of messy text, the speed is incredible. An 18-hour coding process that usually requires constant human troubleshooting now happens flawlessly in under 45 minutes. The Omega engine succeeds because it separates the high-level planning from the mechanical typing. It handles the thinking, so the software generation becomes an instantaneous, perfect result. An engine that can endlessly expand and build its own flawless software is a powerful tool. To ensure safety, this power is kept behind a hard physical boundary. The engine is incapable of releasing its creations into the real world on its own. When the build is finished, the engine freezes the entire structure into a final, locked snapshot. It sits perfectly still inside a digital quarantine, waiting for review. Releasing the software requires a physical hardware key, turned by a human operator. This physical signature anchors the digital logic to our reality. It is the final, essential step that grants the engine permission to move from a blueprint into a live operation. This hardware-level requirement guarantees that a person is always the ultimate authority. The machine can build the world, but only a human can turn it on. We are moving from a world where AI guesses what we want to one where the machine understands the underlying math of our intent. The automatic lattice and the Omega engine provide the stable, reliable groundwork for the next stage of our digital world. We no longer have to hope our systems work as intended. Now we can build a future that is mathematically proven to be correct, one flawless block at a time.